Hello, good afternoon, everyone. Thank you for joining this workshop. Okay, is it better? Okay. Thank you for joining this workshop entitled Fueling the Future of Nuclear, Advanced Fuel Solution for Next Generation Nuclear Reactors. I'm Alice Dufresne. I work at Framatome Fuel, and I'm in charge of fuel product development for light water SMRs. Okay, so as you all know, there is currently an increasing need for clean energy, aiming to decarbonize our energy mix, and this is going to only increase. And part of the answer is, of course, nuclear. And within nuclear, it's small modular reactors. And we've decided for this talk to divide them into two categories. Advanced modular reactors for Gen 4 type SMRs, and light water SMRs will be referred to as SMRs. So with this growing demand, there is a huge variety of concepts under development. Depending on the sources, it's more than 100 concepts in development. And in this changing landscape and very active landscape, Framatome Fuel is committed to developing and delivering cutting-edge fuel solution for the next generation of nuclear reactors, building on over 60 years of expertise. For AMRs, in particular, the focus has been put on two types of AMRs, high-temperature reactors and fast breeder reactors. For the first one, of course, relying on TRISO fuel, Framatome is actively engaged in the support of HTR project with manufacturing capabilities, fuel expertise, and innovation. So this is divided along three axes. The fuel manufacturing pact, that is more based in the US, but also in Europe, to have a sovereign TRISO fuel manufacturing production in Europe. And in the US, it has been recently announced that a joint venture with Standard Nuclear has been launched recently for TRISO fuel manufacturing. But fuel manufacturing is one thing, and there is also the HALEU deconversion process. And then comes the qualification and licensing so that it can really go into nuclear reactors. And the third axis is also, of course, the design work that comes with it and all the innovations in terms of process that will allow reaching a full industrial scale manufacturing capability for TRISO fuel. For fast breeder reactors, of course, Framatome is building on its expertise, on its past involvement in the French programs for Phoenix, Super Phoenix, to support fast breeder reactors projects. So this comes with taking advantage of the advanced manufacturing capabilities and processes for example, the metal fuel manufacturing that is relying on a robust supply chain that has already been used for the French program in the past. There is also significant work done or to be done in the area of fuel assembly design and licensing so that really this fuel for fast breeders can come to a reality on time to meet market demands. These new developments in Framatomes are structured in an innovative reactor fuels hub. This initiative is a strategic initiative from Framatome. It's building on its network of design centers, but also prototyping centers, and going up to the industrial scale, allowing for the full manufacturing and delivering of the fuel. And this innovative fuel hub will have its dedicated pitch at the Framatome booth Thursday afternoon at 2:30, and is serving the needs for advanced fuel, so TRISO, fast breeder reactors, but also serving the needs of light water SMR, so SMR fuel production, taking advantage of the prototyping facilities we have, the manufacturing capabilities, of course, taking advantage of the design that can be done with our engineering teams located in 3 countries, in the US, but also in Europe, in France and in Germany, allowing to keep some European sovereignty on some of the developments. All right, so I will now move on to the fuel for light water SMRs. For this, we know even for light water SMR, there is a huge variety of concepts under development, and a portfolio is developed for these new SMRs. They require tailored fuel solutions because even if they are building on the existing fleet, they have diverse needs and in terms of timeline, in terms of design. So we need to build on the qualified existing fuel products for PWRs and BWRs to accelerate the SMR fuel development. This is possible thanks to the fact that at Framatome, we can rely on proven technologies for PWRs and BWRs, but not only on the technologies, but on the underlying supply chain, which is already existing and ready to support the development of light water SMRs for their fuel part. The solution, the portfolio solution relies on this existing standard technobliques that can be combined with a modular approach to answer the needs, but also to maximize the technical and economic performance of the fuel that will be proposed to light water SMR reactors. With the novelty that comes with these SMRs, there is also the aim, beside the modularity, to develop value-adding features for the performance, the reactor performance, but also the economic performance of the SMRs. And this is only possible thanks to an active engagement with SMR developers to ensure alignments between the reactor needs, the SMR economics, and the proposed fuel product solution. So this approach is really developed to support near-term development while improving the value proposition of light water SMRs. Okay, and I will leave you with a short video.
At Framatome, we're dedicated to developing advanced fuel solutions for the next generation of nuclear reactors. Small Modular Reactors, or SMRs, represent a great opportunity to support the continuous evolution of nuclear energy. We're leveraging our best-in-class, proven PWR and BWR fuel product lines to support our SMR customers by realizing fast development and ensuring reliable readiness through our robust international supply chain. By combining licensed fuel designs with innovations like simplified architectures, optimized fuel cycles, including LEU+ with enrichment above 5%, and enhanced safety through our ProTect solution, Framatome delivers tailored fuel products for SMRs. Our goal? To support customers in designing, qualifying, and delivering safe, efficient, and innovative fuel for tomorrow's reactors. Let's make SMRs a sustainable reality.
Okay, so thank you for listening. I'm Gwen Bolsé, in charge of fuel product development at Framatome, and I will come back on a few of those statements that we've seen already on the video. You've understood it also from the speech from Alice. Our strategy in terms of fuel development from SMR is really to rely on proven products. So we do have our standard product at Framatome on PWR, pressurized water reactor, which is Gaia, with 17 by 17 array with an extensive operating experience feedback. This is, of course, an asset to go fast on the market on SMR, on PWR SMRs. And in a similar fashion, on BWR, we can rely on Atrium-11 technology, which is also well experienced and fully proven on the current fleet. So this is a starting point in terms of design, in terms of operating experience, in terms of licensing, in terms of supply chain, in terms, I would say, of the full range of simulation capabilities as well. At the same time, it was said the SMR needs to are all specific. There is a variety of them, and they need some limited adjustment or extension, maybe, of the capabilities of our simulation tools. And this is what we are doing today. You have an illustration on the slide of course, that's obvious. But if the length of the fuel assembly is not the standard one, this requires an adjustment. We are able to do that. We have, of course, the manufacturing capability, the shipment capabilities, and as well as the simulation capabilities in case, again, the operating conditions in terms of thermal hydraulics, for instance, or whatever, temperature are a little bit different. So relying on proven assets, proven products, proven technologies, and performing the right level of adjustment in order to fit the need of the SMR developers. If I illustrate a little bit what those adjustments can be in practical terms, if we think in terms of fuel economics, of course, the neutronic design of the reactor, the neutronic design of the fuel assemblies is really key. And we are proposing high-resolution neutronic design, which means basically locating the uranium at the right level of enrichment where it provides value for reactor economics. Similarly for poisons, burnable absorbers. And we do have tools, if I go to the right part of the slide, with a Fargo tool, which has been presented earlier in the afternoon by Joanne Planchet, which is an AI-based tool allowing the engineers, in fact, to really make the best possible neutronic design at the scale, again, of the reactor, of the core design, or at the scale of the fuel assembly, with very significant benefit in terms of fuel economics. And we can also leverage the possibility to use uranium above 5%. You may know that Framatome is engaged today, especially on the US market, to provide that capability from 2027 with very significant investment at our plant and also in our licensing system, I would say, to really allow our US customers on the install base to go to longer cycle thanks to the use of higher enrichment, above 5%. This capability will be available, of course, also for SMRs, providing more flexibility to make the best use of the investment in the reactor, let's say. So really supporting reactor economics, which is one of the key driver and also success factor, of course, for nuclear in the future. Another illustration of value adding for customers, if we talk of light water reactor SMRs, is Protect, which is the Framatome Enhanced Accident Tolerant Fuel Solution, which is technically, we are talking about a chromium layer on the cladding to enhance the performance in operation and also in postulated accidents, and also chromium doping in the pellet in order also to reach better economics and better safety. Today, Framatome is in the final stage of qualification of this technology. We've reached a very high burn-up of 73 gigawatt-day per ton. We are the first in the industry to have reached that, and we were first in the industry back in 2019 to introduce the first full-length Protect fuel rod in a commercial reactor. Same in 2021, first in the industry to introduce a full fuel assembly in a commercial reactor in the US. And we are also building industrial capabilities today in order to be able to deliver reload. And we also see some market traction for that with probably some announcement that we would be able to do rather soon in terms of real delivery, commercial delivery of that product. So this product is today developed for the install base, but it is of course considered in the development. Its compatibility for SMR conditions is fully considered as part of the development, and it's also a value adder for SMR as a reactor system, I would say, in terms of economics and in terms of increased safety and what comes with safety, like public acceptance and so on, which is probably which is key for all nuclear, but also quite important for SMR, considering localizations. Another illustration of what we can do in terms of adjustment or fit to use for SMR world. There is a variety of SMR projects today which rely on natural circulation, which means in technical terms and technical conditions for the fuel assemblies, very different requirements as the one that we observe today on the install base. For instance, pressure loss. The hydraulic pressure loss of the core of the fuel assembly is really key in those reactors, key to the performance of the system. And we can, through a modular approach, work on simplification of the fuel assembly product in order really to adjust the design to the need and to reduce the pressure loss. Also, if we think about mass flow in the core, the mass flow is much lower, and so the hydraulic excitation, which is also one of the key elements when designing the fuel assemblies, are much lower. The requirements are lower, and we can leverage that in order to simplify the design and to, let's say, add value, like reduce maybe the cost, or simplify, reduce the lead time, or simplify the design. So there is probably, starting from the same technology, proven technology, opportunities through modularity to really adjust, in fact, the solution to the specific need. Of course, the supply chain, we've mentioned that. Manufacturing capabilities, manufacturing facilities, we are leveraging that. Supply chain is also all the qualification of the process of the suppliers in which we are practicing today, every day. In fact, for our current customers, this is leveraged, and it's really key to be able to one back, sorry for that. To stay within that frame, let's say, to start with the same pre-material, to really think in terms of industrial capabilities from day one, from the beginning. And this is really, we are an industrial partner, and this is also what we bring to SMR developers, to think long term, to think industrial supply chain. It's also about using, beyond supply chain, using our capabilities, current capabilities, simulation tools, testing capabilities. Framatome has a lot of assets in terms of testing capabilities, which are key to qualify fuel products. And those testing capabilities can be easily adjusted to relevant SMR conditions. Also, we do have fuel services to make measurements on irradiated fuel assemblies, for instance, or potentially repair on irradiated fuel assemblies. And those tools and capabilities can be also easily adjusted to SMR conditions. So the idea is really to rely on a proven infrastructure to go fast on the market. And I come to our last slide. So you've understood it. We are really ready to support and committed to support the SMR and advanced modular reactor fuel journey. On light water reactor SMRs, the point is really to rely on proven technologies and to make tailored adaptation as required, and also to rely on a very robust supply chain in a wide sense. The concept of adaptability, modularity to really fit to the need, and also, of course, leveraging Framatome expertise in terms of phenomenological understanding, simulation, testing, and so on, and licensing. Also, licensing is key in nuclear in order to make this real and to make this real fast. And that's it. Thank you very much. I understand that there is the opportunity to ask questions probably in the box on your left for some time. Thank you.